So one of the most necessary actions in metalsmithing is the act of cutting. We always find ourselves in positions where we need to cut something. And there are numerous ways to cut. One of the ways that you're probably most familiar with is to use some sort of a knife or a blade. Now these are really handy for things like soft materials like paper, wax, wood, that sort of thing. So this is my X-Acto blade. It's a very small, very accurate blade. With X-Acto blades, you always want to make sure that you have a fresh, sharp blade in there. We all know that a dull blade is more dangerous than a sharp blade because you have to work harder to do your cuts. And so anytime you buy an X-Acto knife, make sure you get plenty of extra blades with it. The X-Acto knife can be really handy for making long, straight cuts on your material. If you're doing a cut like this, make sure your fingers are behind the ruler. Don't have them sticking over. I've seen that happen. And with a metal ruler, I can easily just go down that surface and I get a nice long straight cut. A cool thing about the X-Acto blades is if you're working with manila folder material, which I highly recommend, it's a fantastic material for model making. If you're working with a manila folder or cardstock, it's just really nice because it's stiffer than your sketchbook paper, but not so big and bulky that it's difficult to manipulate. I can take my X-Acto knife and I can hold it upside down. And if I score that line, holding it upside down doesn't cut all the way through, but I get a super, super nice, accurate fold. You can do this on curves. You can do all kinds of different accordion folds, zigzag folds. I have a book exclusively on paper folding and cutting. Other types of knives that are handy in the studio, utility knives. Same thing, make sure there's a fresh blade in there. Don't work with dull blades. And then, you know, even your kitchen knife could be useful if you're working at home. You want to cut some wax or something like that. You know, but once again, knives primarily are going to be used for our soft materials. Okay, so next up we have a selection of shears. A shear is basically any cutting implement that has two blades that are really close together. And as those blades come together, the material that's in between them essentially tears or it shears. Okay, and I keep overpronouncing the SH when I say shear because shears are only to be used with sheet material. So obviously, you know, you're used to seeing a standard pair of scissors. They cut sheets of paper really well. I think most people are used to seeing this type of shear. I think a lot of people call these snips. I don't really like using the word snip. I call them hand shears. You can see on this one, maybe if I hold it up, you can see those lines that are in there. Those are nicks in the cutting blade. That means somebody cut some wire with this. Those nicks in those blades are going to be transferred as little bumps in every single piece of material that these shears cut from now until the end of time. Never, ever, ever cut wire or rod with shears. Shears are only for sheet. These are kind of an offset jaw. I tend to call these aviator shears. The offset jaw gives you a little bit more leverage and a little bit more control in your cut. Now, red-handled shears are good for cutting turns counterclockwise. Green-handled shears are good for cutting turns clockwise. Shears are really great if you want to do a quick outside cut of your material. Now there's definitely some downsides to shears. With shears, you're always going to end up with needing to do a significant amount of cleanup on that cut. Because the way, just the nature of the shears working, that material tears, you're going to end up with a burr on there. Also, the piece that ends up being discarded, typically on a pair of shears like this, it's whatever material is on the right hand side of that shear, the side that's being pushed down. Whatever material is on that side is going to be distorted pretty significantly. So shears are good for doing, you know, quick cuts, but they're not very accurate. These are just some heavier duty small metal shears that are more in the style of your scissors. Okay, so this is our step shear, and just like all the other shears, it works by having two blades come together and basically cut whatever is in between them. This is an excellent tool for doing long, continuous cuts across the surface. So I have a line scribed the whole way across here, and then a bunch of little lines that I'm going to cut on this tool. Now, the way this tool works is you're going to put your material underneath the finger guard, and basically I'm going to line up my line with the blade that functions as the table, and I'll show a shot of this in a minute. And so I line up my metal with the table, and then I'm going to very carefully step on the step. And the very first thing that happens is the finger guard comes down and presses against that material. The finger guard is intended to do exactly what it says, to guard your fingers. This thing will remove parts of your body if it's caught in the blade. So the finger guard prevents you from having your fingers under there. What the finger guard doesn't prevent is smashing the heck out of your fingers. So if you accidentally have your finger under the finger guard and you step on this step, you're going to know real quick. It's going to smash your finger, maybe your fingernail will fall off, but your finger is still attached to your body. So the very first thing that happens is that blade comes down. Now it's really difficult to see, but maybe you can see that line right there. And so what I'm doing is I'm lining both ends of my lineup with the table. You can see the edge of that table, that little space right there. That's what I'm looking for. I want my line to be on the table. You want to make sure you're lining it up with the table and not with the blade, because the blade is set at an angle. And if you line it up with the blade, you're going to get a crooked cut. Okay, so I'm lining up my line with the table. I'm going to step on the step. The finger guard comes down. The finger guard also prevents your metal from cantilevering up when that big blade comes down to hit it. The blade comes in contact, and I gently stepped on this. You don't have to be quite so gentle, but you do want to take your time because you don't want things to shift and cut in the wrong spot. If you're cutting something that's very wide, sometimes the blade doesn't go right through it, or if you're somebody that doesn't have a whole lot of body mass, you might have some difficulty getting that blade to cut through your material. In that case, you can easily ask somebody else to join you up here, or you keep one foot firmly planted and you stamp with your other foot. Do not jump. I hear people call this machine a jump shear, and I don't like to use that term because you should never jump. If I were to jump, my whole body comes up off the step. The finger guard comes up and my metal could shift, and then boom, I come down with my full force in the wrong position. Next up we have our wire cutters, or these are technically called sprue cutters. They're made for cutting thicker material, and they're made for cutting solid material like wire or rod, or the sprues for your castings. The way the wire cutters work is you have two triangular pieces of material that basically pinch whatever material is between them until it breaks. Typically, if it's a very small amount of material, that's going to shoot out there like a rocket. So you really want to make sure that you're paying attention to where the material is going. Wire cutters have a limitation. I mean, there's a reason they're called wire cutters. They're not really intended for cutting material that is substantial. So if you're using a pair of wire cutters and you're squeezing and nothing is happening, that material is probably too thick for your wire cutters. These are just our traditional cheap wire cutters. They work really great for making a whole bunch of cuts. You can see those pieces of wire just going flying, but if I hold the wire cutters down on the table like this, all those little pieces end up in a nice little pile. These ones are very similar wire cutters. They operate the exact same way, only these are called flush cutters. Basically what they've done is they've changed that angle, so instead of two triangles coming together equally, they're kind of offset a little bit, which gives you more of a flush cut. Now you're still going to end up with a peak in your wire. You will always end up with a peak in your wire when you're using wire cutters. And so even with the flush cutters, there's still a little bit of material that you would need to address. But once again, they work exactly the same. And like I said, you end up with a little bit more of a flat end instead of that peaked end. If you're trying to cut through some material with the wire cutters and it's just not doing the job, you know, if I had something like this, which would be terrible, you know, and I'm trying to cut through this really thick material and nothing is happening, you need to step up your game. You need to go with something bigger. Now, the sprue cutter works essentially like a miniature bolt cutter, where you have this additional hinge in here and it gives it a lot of leverage, but it still operates the same with triangular pieces of metal coming together to pinch the material. And they make pretty easy work on material this big. I don't know if I would use it for material this big. For something like this, I would just go ahead and use the saw. So the last cutting tool that we use, and it's probably the tool that we use most often for cutting here in the Metalsmithing Studio, is the jeweler's saw. This is the most versatile of all the cutting tools. It's also one of the most accurate of all of the cutting tools. Basically, to adjust the saw frame, you can undo this wing nut here and loosen or tighten the tension on your saw blade. This wing nut and this wing nut hold the saw blade in the saw. So this is a dozen saw blades. They're very tiny. This is actually a dozen of the number 2 saw blades, which are some of the more aggressive saw blades that the bookstore sells. The bookstore doesn't have a huge range of saw blades just because we really don't need to have tons of them on stock. But the way saw blade sizes work is 0 is in the middle. So as those numbers get bigger, 2, 3, 4, 5, the saw blades get bigger. As the zeros get bigger, the saw blades get smaller. So 0, 1, 0, 2, 0, 3, they're getting smaller as you count up. Saw blades get ridiculously tiny and ridiculously big. We kind of went with the average for what's available to you. So to put the saw blade in the saw, what you're gonna do is there's like this little nose right here. You're gonna rest that nose against the bench. The handle of the saw blade is pressed into my sternum. I'm going to take my saw blade, and the way that I can't really see the teeth on the saw blade. They cut in one direction. So the way to tell which direction your teeth are cutting are hold the saw blade by one end. If you can take your finger and run it along, I happen to be holding this saw blade from the top. If I had been holding the saw blade this way, holding it from the bottom, I can't run my finger along that saw blade because my fingerprints are getting caught in those teeth. So I want to make sure to put the top of the saw blade all the way into its little clamp. Okay. Now I need to adjust my tension. What I want is I want about 1/4 of an inch overlap between the bottom of the saw and the bottom clamp here. If I have less than that, I'm gonna have to put way too much tension on this and I risk just breaking the blades outright. If I have too much overlap, I'm not gonna be able to get enough tension on this blade, and the saw blade is gonna hit this part of the saw frame and it's not going to allow me to put enough tension on, and you know, you really can't cut well with a wobbly blade. So, now I have the proper amount of overlap. I don't know if you can see that, the saw blade is very tiny. I'm gonna put the saw frame against the bench, I'm gonna lean forward, and as I'm leaning forward, I'm gonna tighten down that bottom wing nut. Your saw should hold a tune, okay? If it doesn't hold a tune, you probably don't have enough tension on it. Also, just to double check the direction of your saw frame, a friend of mine, Arthur Hash, made a t-shirt with a picture of a cat superimposed onto the saw frame. And basically, you know, when you're petting a cat, you can only pet your cat from its head to its tail. From its head to its tail. You can't pet a cat backwards because they will claw your brains out. Okay, so I just drew a little squiggly line on this. Basically, what I'm gonna do is I'm gonna travel along that line and demonstrate how nimble the saw is. When you're sawing, you want that saw to be straight up and down. If I am cutting at an angle, I'm actually increasing the amount of material that I need to cut through, almost by 3 times. And so you want to cut straight up and down, but to get the cut started, you can kind of come in at a little bit of an angle. Always put what you're cutting in the V of the bench pin. That way your saw can ride in that V and your material is supported on both sides. If I overhang my cut and I'm cutting off the edge, that piece of metal is going to want to bend and torque every time I pull down on it. You could cause yourself to break a lot of saw blades. Also, when I'm holding my saw frame, I'm holding it nice and loose. You know, I'm not like squeezing the life out of this thing. And you also don't want to push the saw forward. You just want to allow the saw to cut and remove the material. So, get my cut started. And then it's a matter of moving your saw or moving your material around. The saw itself really shouldn't move that much. Also, I have my body sitting a little over to the side of the bench pin. That way my arm can be straight coming off my body and it's not coming across my body. Okay, so here is my 2 pieces. And so you can see how nimble that saw frame is. Now, obviously, this cut isn't finished. I would need to get in there with my needle files, you know, and I would need to file those edges and get them really nice and clean and all of that stuff. But the saw is incredibly nimble, and it's also incredibly strong. These little jeweler saws can cut through a heck of a lot. The next thing I'm going to show you is a piercing. Now, in the drilling demo, I used this piece of wood, or piece of metal, and I drilled a couple little holes. So I'm going to cut out this little cloud shape. And if you can see the cloud shape, it's got these little peaks, right? The saw blade is nimble enough that I can turn it around in the cut and cut out those little peaks. Now, there's a good chance that if you draw on your metal directly like this, you're gonna rub off the Sharpie just with your fingers. So a little trick is just to get some clear tape. I got some Scotch tape right here. I'm just gonna tape over that image. I can cut right through it, okay? You can draw your image on a piece of paper and glue or tape that piece of paper directly to your metal and cut right through it. So you don't have to keep redrawing everything. So I'm gonna poke through these holes because what I need to do is I need to undo my saw blade and I need to insert that saw blade into one of those holes. Now, I'm going to cut over to my line. And start cutting out my little puffy cloud here. And so right here I have my first sharp bend. So what I'm going to do is I'm going to continue the sawing motion and I'm just going to turn the saw blade in that cut and I'm able to go right around this line. Okay, so a piercing is anytime you cut out a shape that is contained within that piece of metal. So anytime you're making a complete negative space. Okay, so enough about sheet metal. What I'd like to talk about next is using the saw to cut through thicker material like this brass rod or even this really heavy, thick copper wire, or even, you know, your sprues from your castings. Those are all fairly thick materials, and the issue is that saw is passing through a lot thicker stuff. And so when it's passing through a lot thicker material, there's more saw blade that's trapped within that cut. That means if I flex this way or that way, I'm much more likely to break the saw blade. So I need to be very, very stable when I'm cutting through thick material like this. And so this particular piece of brass rod, I can hold on to it very easily. And so I can be really nice and stable, and I could cut this on the bench pin without too much trouble. But I might elect to use something like this. This is our tubing cutter jig. This will hold that rod right down in that V-shaped trough, and then I can use my saw to just go ahead and cut through this thick material because it's being held in one spot. So I just pass through all of that and I get a nice clean cut. I still could have totally used my big sprue cutters, but they tend to leave quite a peak in that cut. And so you know, it's kind of a trade-off. Do you want to spend your time sawing, or do you want to spend your time filing? I could have used this one too. The $1 million tool works great for holding rods and things of that nature. And so this is going to allow me to be very stable in my cut as well. Something else that I can use my ring clamp here. And so if I clamp my ring clamp, now I have something bigger to hold on to. I can hold this against the bench like this and begin to cut down. Now in the case of this is a tremendously thick sprue because this was made through cuttlebone casting. I want to keep my saw blade away from my object just a little bit. I don't want to cut into that object and risk you know, cutting deep into my form, because then that's going to cause me more work, or I could even, you know, ruin that casting by cutting too deep into it. So I'm going to be really nice and stable here. And so you can see, I don't know if you can see on the camera, you can see how thick that is. And so I would even elect to maybe not use the ring clamp. I'm going to use my little bench vise right over here. Okay, so I've gone ahead and I put some masking tape on my vise. The reason why I did that is because the vise has steel jaws, and this cuttlebone cast anvil has a really nice texture to it. If I clamp it into the vise without putting something on here to protect it, it's going to smash that texture and it's going to leave marks from the vise. So if you see tools with masking tape on them, the reason why there's masking tape on there is because somebody wanted to protect their work. Now I'm going to ask that if you do put masking tape on something like this, that you remove it when you're done. Masking tape gets kind of gross, and you shouldn't have to clean up after you. Okay, so I was able to cut through this entire thing, and I only broke 2 saw blades. One of the things that I did that helped me in this process, see that? See how I left myself some to file away? One of the things that helped me in this process to cut through all of that bronze is lubricating my saw blade with a little bit of candle wax. We have a couple candles floating around in here. That's what the candles are for. So there's lots and lots and lots of different ways to cut stuff in this studio. You're going to find that the saw can be a little challenging to get used to at first, but it's amazing in what it can do, and you're going to find yourself using it quite a lot. And so the sooner you start using your saw, the better.